Okay, mass is released from the top of a smooth ramp of height h. Okay, after leaving the ramp, the mass. Okay, I have not switched on the timer. Right. Okay, after leaving the ramp, the mass slides on a rough horizontal surface. So until here it comes without any friction, and when it comes over here, there is a friction, which is shown here by these lines, right? The mass comes to rest in a distance d. So why does it come? Because the energy has been lost over here. What is the coefficient of dynamic friction between the mass and the horizontal surface? Now, so therefore, now what we do is, the energy which it has here is nothing but mgh. When it comes here, the mgh keeps on reducing, kinetic energy keeps on increasing, and at this point, the kinetic energy is going to be half mv square. And at this point, it has lost all its energy, it has become 0 over here. Okay, total energy is 0. Okay, now let us find what is the velocity at this point. Velocity at that point is half mv square is equal to mgh, because it has got converted, and thus you can write v square equal to 2gh, or v equal to square root of 2gh. This is what is the speed at this point. Now when it comes over here, it is 0, which means what? Now let us use v square equal to u square plus 2as to find out the value of mu. So therefore now what happens here? So u, what is u here? U is the initial velocity at this point. V is the final velocity. This is your final velocity, this is your initial velocity. So v is equal to 0. U square is nothing but v square, which should be 2gh plus 2 into a. What is a here? Let us draw the free body diagram. This is my normal, this is my mg. So n should be equal to mg. And what is the only force acting here? There is no force acting in the forward direction, because there is only friction which is acting in the backward direction. Thus, frictional force is equal to mu times n, which is equal to mu times mg. So, but on Newton's second law, I can now write this as m times a, or a should be equal to mu times g. And this a is in the opposite direction, right? It is trying to slow down the object. So I will write this as minus mu times g multiplied by, what is the distance traveled? D over here. D over here. So initially its velocity was u here, and as it kept on going, because of friction, it started slowing down and reached a point at a distance d because of the friction, and we have accounted for all of them now. Now let us continue. So therefore 2gh is equal to 2 times mu g into d. 2 gets cancels, g gets cancels, and I want only the value of mu, which should be equal to h by d. Thus the answer is equal to h by d, which is option D. Okay, let us move on to sixth question.